In this lecture, we are going to discuss how to determine the order and type of the system. It is important to know the order and the type of system because if we are aware of order and type of the system, so how that system is going to behave based on the given input, we can predict it beforehand. So let's see what we are going to cover in this lecture. We are going to discuss how to determine order of the system, how to determine the type of system, and then we'll take up some example to understand how to get the order and type of the system. So let's start order of the system. So we know that we can represent any linear time invariant system with the help of a differential equation, and that equation we are going to get based on the mathematical model of the system that we have derived by applying the physical law that it is going to follow, and solving the differential equation to get the response of the system based on the input is a bit difficult. But the simple way of getting the response of the system is to get the transfer function of the system. So transfer function of any system we can get by applying Laplace transform to the differential equation of that system. And we take the initial condition to be 0, and based on that we can write the output upon input, and that will be the transfer function of the system, and that we get in this algebraic form. So once we are having the transfer function of any system, so how to get the order of the system? So suppose we are having the transfer function and it is in this algebraic form. So what we have to do, we have to see the power of s. So the power of s in the denominator of the transfer function will going to determine the order of the system. So whenever we are having the transfer function of any system, we need to just write it in this form, and then we have to see how much is the power of s that we are having in the denominator, and that power will going to represent the order of the system. So let's take an example. Suppose we are having a transfer function as g of s into h of s, that is an open loop transfer function, and it is given by k into s plus 1 3 divided by s square plus 10s plus 21. So from this transfer function, we have to see how much is the power of s that we are having in the denominator. So we can see here that s is having power of 2. So that means it is a second order system. Similarly, we have to just see how much is the maximum power that we are having for s in the denominator, and based on that we can comment on the order of the system. Let's take another example. Suppose we are having g of s into h of s is equal to 1 by s plus 3. So now here we need to see again what is the power of s. So here we can see that it is 1. So this system is a first order system. So in this way we can determine the order of the system based on the transfer function that we are having. Now let's discuss how to find the type of system. So here we are having transfer function of the system in algebraic form. Now what we can do, we can factorize the numerator and denominator, and we can write the same transfer function in this form. So here what we did, we have factorized numerator as well as the denominator, and we got this form. This factorized is also called as pole and zero form. So here the z represent the zero of the system, or zero of the transfer function, and p represents the pole of the system or pole of the transfer function. Now here if we want to define the zero of any transfer function or zero of any system, similarly pole of any transfer function or pole of any system, so zero of the system is that value of s in the numerator that will going to make the transfer function 0. So that is called as the zero of the system. Now similarly, when we talk about the pole, so pole is that value of the s in the denominator that will going to make the transfer function infinity. That value of s is called as pole. So whenever we want to get the type of system, we need to always write the transfer function in this factorized form, and the number of poles that we are having at the origin will decide the type of system. So let's take an example to understand this one. Suppose we are having g of s into h of s, and that is equal to k by s square s plus 2. So now here in this transfer function, we have to determine how many poles that we are having at origin. So what we need to do, we need to equate this s value in the denominator to 0. So here we can see that we will be having s square is equal to 0, and similarly s plus 2, that is equal to 0. So from this equation we can say that we are having two values of s that is at 0. So s indicates what? It is a pole. So here we can say that two poles are at 0 value, that is at the origin, and this pole is at s is equal to -2. So it is at -2. Now from this transfer function we know that we are having two poles at the origin. That means it is a type 2 system. So whenever we are having a transfer function, we need to see how many poles we are having at the origin. So it will be simple as with power. Okay, we should not have s with some constant, okay, in like in addition or in subtraction. If we are having a separate s, so we need to just check its power of s will define the type of system that we are having. So let's take one more example. Suppose we are having g of s into h of s, and that is equal to k upon s plus 2. So now in this case, what is the type of system? Now here we can see that we are not having a separate s. This s is with some constant with addition sign. That means this pole we are having at -2. So we are not having any pole at the origin. That means it is a type 0 system. So similarly, we can find the type of system. Let's take a few more examples to understand how to get the order of the system and the type of system. Suppose we are having g of s as k 1 plus 3s upon s square, and we are having h of s is equal to 1 plus 5s upon s square plus 6s plus 7. So we can write the open loop transfer function as g of s into h of s. So here it will be k 1 plus 3s upon s square, then into 1 plus 5s upon s square plus 6s plus 7. So now here we can just rewrite it as in a proper multiplication form. So it is 1 plus 3s, 1 plus 5s upon, it will be s square plus 6s plus 7. Now if we want to find the type of system, so we know that here we need to study this denominator. So from this denominator we can make out that we are having separate s which is having power 2. So based on this one we can say that we are having two poles at the origin, because it is a separate s that we are having here in the denominator, and it is having power 2. And also we need to check whether we can take out more common s here, but we can see that we cannot take it out. So this system is type 2 system. Now in order to find the order of system, what we need to do, we need to multiply this s square inside so that we can have a proper algebraic form. So it will be k 1 plus 3s 1 plus 5s upon, it will be s raised to 4 plus 6s cube plus 7s square. So here we can see in the denominator the maximum power that we are having with s is 4. Based on this one we can say that it is a fourth order system. Let's take one more example. So we are having a g of s is equal to 4 by s square plus 6s plus 7, and we are having h of s is equal to s plus 3. So now this one we can write it as g of s into h of s, and that will be equal to 4 s plus 3 upon s square plus 6s plus 7. So now what is the type of this system? Now we can see here we cannot take out s common, so we are not having a separate s here. So that means we are not having any pole at the origin. So it indicates it is a type 0 system. Now let's find what is the order of this system. So here we can see it is in a proper algebraic form, and the maximum power of s that we are having here is 2. So based on this one we can say it is a second order system. So in this way we can determine the order and type of the system. So in summary we can say that whenever we want to know the type of the system, so in denominator we have to take out s common. So if we are having a separate s, and the power of that s will indicate how many number of poles we are having at the origin, and that defines the type of the system. And when we want to find the order of the system, we need to multiply all s, and we need to write in a proper algebraic form. In that we need to find what is the maximum power of s that we are having, and that power of s will going to define the order of the system. So in this way we can make out from any given transfer function what is the order of that transfer function or that system, or what is the type of that system or that transfer function. So with this we'll end here.